sharing 되고 있고. Can you go to full screen? Sure. Okay, thank you very much. All right. This is 3 p.m., so we can start. This workshop is for like a data analysis workshop for R and SPSS syntax, and we will have two different sessions. One is like intro session, and the other is like intermediate sessions. And here, the reason we're providing this workshop is because like many applied researchers have difficulties in using the SPSS syntax, and also like some software, especially like using the syntax-based program. So we will provide some kind of basic training things. And so at the end of this session, you guys be able to use syntax-based program as well as the SPSS. So here, we have a guest speaker, the Dr. Jaehwa Choi, and he will give the first session with SPSS, and I will give like the second session with our program. And before start, I want to give some the brief overview what we will be covered in this first and second session. And the intro session, we will like explore some basic stuff in SPSS and R. And Dr. Cho will cover like SPSS syntax and statistical modules, and specifically like in the basic inferential statistic, but that will be done with SPSS syntax. And in our session, I will give like the brief description about R and our editor, which is called RStudio, and then I will go over data management in R, and then I will kind of copy or mimicking Dr. Choi's analysis so that you guys have the same stuff in the session, but more likely to the experience in different programs. And after that, like we will provide another session in November 17th. And in the cases like we will kind of dive into the statistical modeling. And I just briefly read the write as general linear model, including analysis of variances and regression model. So Dr. Cho will give like the additional or advanced statistical modeling. Also he will provide or analysis with SPSS syntax, and he will go over some the data management in SPSS. And I will also go over the general linear model in our program, and I will do like some other additional the analytic the techniques in R. And if time permits, and I will go over some the basic simulation studies, so you guys can apply the simulation studies in your study. Okay, so this is like the overview of two sessions, and then let me just give this presentation the mic to the Dr. Jaehwa Cho. Okay.
All right, thank you so much. Yeah, let's do it. And I just want to check what's going on in here. All right. Yeah, I think there's one viewer right now in the online. This is also live on the YouTube channel. So this is first time we didn't fully announce the how, when, and where we get it into this live session. So GW students are able to get into this session through online. And yeah, see what's going on. I'm very excited, and this is like excited because number one, SPSS syntax and R, and this is very important training, but not necessarily we able to integrate those training into formal course workshop in assessment and testing measurement program in GW. But it's very needed, especially when we are looking for a job. and this training definitely highly appreciated too, especially when you do the professional work. And I'm also interested in this one because last semester, Dr. Ryoo come to GW, provide workshop for GW students. So this is another revenge turn, and I will come down to UVA. It's very exciting, and beautiful campus, and I'm very honored to be here to meet UVA students. And third of all, it is also excited. This is first time to do this live and face-to-face session at the same time, and two different university and many different programs. And I also advertise this one to Facebook, ATM page. So someone who saw that ATM page, someone who liked that button and able to take advantage of this live show, right? So yeah, let's get started, and we do share screen and getting back to our workshop. And at the same time, okay, this is fine. Maybe I will just go ahead to record this one. Go desktop 2, just in case. Okay, do this one. Data analysis and data analysis with SPSS syntax, right? Intro level. My name is Jaehwa Choi. I am a faculty member in Assessment Testing Measurement Program in George Washington University. And I'm in charge of this SPSS syntax part for this workshop. And I will spend about 2 hours in this area. And then Dr. Ryoo will talk about same intro level, but we try to do as much as we could in a parallel way, do exactly same thing with R, right? So it's very, very excited to have that, aligned, contents over 2 different programs, right? Okay, outline of this presentation, we will talk about the SPSS syntax. And the first of all, we will talk about why we have to learn this, right? And then second of all, and I will go over basic syntax rule and how those SPSS syntax is constructed, and definitions and terminologies and structures and et cetera. And then we getting into modules. And module means a special, for example, small program type of thing. And SPSS syntax developed by module based. So we can do independent analysis over different modules, right? And there's a tons of module has been developed in SPSS syntax library. But we will go over a couple of them as intro level. And then we will summarize this workshop. Right, SPSS syntax beyond point and click. The idea is why we have to think about this SPSS syntax. Okay, what is SPSS syntax? The SPSS syntax is because there is 2 different methods running analysis in SPSS. The first method is point and click, drop down menu. We already learned how to do it. Okay, there's SPSS program. Very, very easy to navigate those menus, and we can just point and click, and then we can conduct the most of analysis. We're setting up those options and some specifications, and through those graphical user interface drop-down menu, we call this a point and click method, right? However, there's another way of running analysis, almost parallel way, right? Is using syntax. Whether we know it or not, actually computer treat most of 2 different processes the same way. Traditionally, SPSS has been developed by that syntax way. And then the engine itself is more syntax friendly. But over time, if we have a computer, personal computer, window machine, and people can using software and program, not just simply writing up all those small program. They want to do more like easily conducting research by that GUI, right? Which is drop down or point and click method. So in class over time, what happened? And because there's another easy way of doing it, everybody have a bias of what easy to do it, right? So and even though when I started to my graduate level training, I learned a little bit of those syntax, but I not actually exposed majority of syntax at all, even decades ago when I was a graduate student, right? So, but the reality is once you got a professional job, right, and you will see the very, very different, treatment of those statistical analysis, which is heavily rely on syntax-based analysis, even SPSS and other things, other program as well. The issue is why, and then I will just go over why that happened and why professional society, if you go outside beyond this just coursework training, why people had some endorsement on those syntax-based method, right, or script-based process on statistical analysis. And I will talk about those motivational background together in this part, right? Syntax is programming language, small a special programming language unique to SPSS, of course. And then also this is more like a command-driven way of conducting research, right? Even though many users are not to use this syntax, I agree, and I completely understand, and 99% of the practical users not using this one, but 1% really professionals are really heavily rely on this syntax for some reason, right? And there's a whole bunch of reasons I would like to talk about those things. In short, I want to pointing out two different reasons. One is reproducibility of your work analysis. The other one is communication. Syntax is what? Absolutely fabulous, right? In two criterion, reproducibility of your analysis and communication of your work, right? Because think about, and then what do you mean by reproducibility is what? You can retrace and every step-by-step process of your analysis. Professional work is not as simple to doing one particular job. You have to transform that data and you have to recode into another variable. And then that recoded value, you compute some statistics and then take that statistic plug into another step of analysis. There's like a sequential work you have to do it. At some point, if you do it that point and click method, you have to memorize every step of what you've done it. So after you run analysis and your advisor or coworker want to see that work, and final end is what? The final product is sometimes not retraceable what you have done it, right? But if you use a syntax and your colleague, coworker, and your boss able to review every step by step what you've done it, and then you can fix it. We can fix it, right? So find and correct mistake is a lot easier than point and click. If you, again, sequential work, professional work required like dozens of steps you will do, right? If you want to find a mistake and correct, you have to demonstrate those step-by-step thing in front of other people until other people are able to help you to find mistake, right? That's nonsense. And then also, sometimes you want to reuse that work to apply to that process to another data set, or you want to go back to the data set, change some small, in between steps. If you're traditional method, you have to do it again, everything. So you have to redo entire process one more time. But if you're using a syntax, what happened? If you go back, search that particular point, and pinpoint that particular step, and then modify that one. Like for example, oh, I saved that data set into another hard drive. So I want to change the location of that data set only. You don't have to do every analysis again. You just to change the location of that file, and then you can reproduce exactly what you did it again, right? That's another example. So in the end, what? You save time and effort in the long run. You save humongous amount of time because you don't have to redo and easily modify and easily maintain, and also what? Easily to find a mistake if you use the syntax-based approach for the SPSS analysis, all right? Again, in short, we will call it as what? Reproducibility. And the other one is communication, right? Sometimes you're not doing by yourself. You wanna communicate about what your work and entire process, right? And when you do point and click, what we have done it, and the only thing we did it is what? We sent our SPSS final output, give it to our colleague, and take a look and what they think about it, right? About my work, right? So, but the output sometimes requires a lot of in-between steps. So I cannot explain every step I transform, recode, and delete, and aggregate and sort it out. I cannot explain everything what I've done it by that output file, right? Because I want to explain what I've done it, right? So that's the reason why for communication part, and I want to save it, send it, and explain it, and I got a feedback, right? Everything can be, those professional work can be easily done, way more easily done in syntax-based approach. So more like a major project, professional work, even your dissertation, even that's actually dissertation work, and requires what? Tons of step-by-step process of cleaning up data, right? And then you can save it, and you can reuse it, and then you can collaborate together with that one with your colleagues. So that is the exact reason why we have to think about those syntax approach for the SPSS. SPSS is a very popular statistical package for social behavior, so social science. That is what SPSS stands for, right? So social behavior science, people are very big fan of those point and click, but again, there's a strong need of SPSS syntax. Last time we did a workshop with Dr. Ryoo, and we have attendance came from AIR, and she was very excited about using this syntax approach for the Stata and SPSS, because she didn't learn those things when she was a student, but immediately got a job, and everybody working on those syntax, SPSS syntax and Stata syntax. So there was some, but she was not exposed to those syntax things at all, right? So that was actually sort of problem, and she need to overcome once she get a job, right? Okay, and this is motivation. So we fully understand why we have to consider this SPSS syntax beyond point and click. I think this is it. And then we will moving into what is basic syntax rule and how those SPS syntax is organized and structured, right? And also I will give you a very practical tool, tips, how to easily conquer this SPSS syntax, not learning entire language again, right? Okay, first of all, and we have to get familiarized this SPSS syntax editor. SPSS syntax editor is in, if you go to the very left-hand side, file menu, and click new, and there's some, you can create a new data file, new output, new script, but you can create a new syntax, right? And then if you click that one, and then you're able to see this editor window, and then in this window you will develop syntax and then modify and run it, right? This is like more like a small program window. You can start to writing up the small special program for SPSS. We call this SPSS syntax. Okay, for example, if we got X1 and X2, right? And let's say we want to have what? there's a two variables in here. And if we want to run descriptive statistics, which is, we call it descriptive procedure or module, right? And, and then we use this below descriptive, below part of, I don't know why I cannot see those mouse over it. We can use this syntax and cut and paste into this window, and then select all, run all, right? Or you can select part of them, or you can run everything. And then, ta-da, you will get those traditional, this output itself is very familiar, right? And this is descriptive statistic result output from SPSS process. SPSS give you this output. But in upper side, we can easily see what? There's the syntax we just give it to SPSS, they display that syntax inside of output, right? Let me tell you, by default, students we don't have this syntax is displayed in SPSS output. So we will talk about how to get this SPSS syntax inside of output, and then we can reuse that one again. Okay. Click, and then also if you like to save syntax, and you can click File, Save, and the extension name is what? SPSS, right? SPS is what? SPSS syntax file. So you can save that one, or you can notepad and you can just cut and paste the entire process and give it to your colleague, and they can do it in notepad or inside of email body as well. But also SPSS, you can run it as a special program, SPSS program, understand what that file means. All right, and then if you have it, and then you can change, like for example, if you have this in the middle, descriptives variable x1, and previous step, we run descriptive statistic for x1 variable. If you like to do it x2, if you like to modify it, go ahead to change those x1 instead of x2, and then you can rerun what? Descriptive statistic very easily with another variable, which is x2, right? And this is video. Okay, let's see why mouses cannot be seen for some reason. I don't know why this has happened, but anyway, there's some technical difficulties. I cannot find my cursor, right? Let's try to do this. Oh, there is it. Okay. I'm guessing where is it. Anyway, this is video. I recode every step by step, so you can check this video next time if you are interested into how to do entire process in action, right? Okay, let's move on. Syntax rule. SPSS syntax, they had a color coding. They assigned a different color for a part of syntax, and easy to understand the structure of SPSS syntax. So it's very friendly and thoughtful, and especially we are not very big fan of what? Those programming thing, right? And it's a very, very easy way of understanding those structure of program by this color coding, and for newbies, right? But idea is very simple, and this is actually color coded the example, right? Descriptives is what? Basically procedure name, a particular procedure. When you drop down, point and click, you choose, okay, analysis and descriptive statistics, right? Descriptives. And this is exactly same thing. The menu you choose is the same as what? Nearly parallel to what? Procedure name. What do you mean by procedure is a chunk of function They do specific job. What kind of specific job they're doing? We already know, descriptive statistics, right? So typically they use dark blue as what? Procedure, and all other information is what? Nested within that particular procedure. So we will learn, like for example, today we will learn descriptives, t-test, and graph, histogram. Everything's are what? Special type of functions, and they're doing some special job for a given for a particular statistical analysis, right? Okay, dark blue is descriptives, and then the other one is what? Black one is what? Variable names. Typically, variable name SPSS syntax window using a what? Black. Color is black. So x1, x2, x3, whatever variable name, we use those black. And then also dark red, like variables. Okay, let's go with this green one first. Okay, slash green, slash statistics is what? Statement for that procedure. What is that procedure? Right now, the procedure is what? Descriptives, right? Descriptives, right? And statistic is a particular statement belong to descriptives, right? So inside of descriptive, and we have a statistic statement. This is like a particular job. What type of job, this descriptives looking for. And then compute what? Logically what? Hey, compute some statistics inside of that procedure, descriptive procedure. And when you compute the statistics, and then we are asking what? Mean, standard deviation, and range type of thing. So those things are, we call it as option keyword, belong to statistics. Again, what is a statistic? It's a statement, particular job inside of descriptives. It's its procedure name and using other options. What are options? Mean, standard deviation, and range, right? In English, let me explain entire this script language in English. Hello, SPSS. Please do descriptive statistics, mean, standard deviation, range as an option with x1 variables. Again, basically, this is you telling computer SPSS program what they need to do, right? So, it's very nice. It's a very logically organized, and this is a standardizable, right? And it's very useful, and everybody understands. And computer always understand as soon as you speak that language, right? So, and this is it. And the last one is, last one is what? Dot, 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 dot. Every procedure need to be concluded by that dot. Why I said dot, 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 dot multiple times? Because when I learned this statistics and first time syntax, I got an error message. I bet 99.99% of what newbie mistake came out from missing this dot. SPSS, nowadays SPSS is very friendly enough. They'll tell you, I think you missed that. But and a long times ago, I have no idea why my syntax won't work. I keep getting an error message. And it turns out what? This dot. And then they're very sensitive. Still they improved, but still very sensitive and blank and special character, right? For some reason didn't work out. You have to get rid of entire those unnecessary spaces and not including any special character when you cut and paste. Be careful. Be careful. The SPSS is very sensitive to some incorrect information coming in, right? Okay, and the comments, you can use asterisk. And if you put in asterisk first, entire that line, they consider as comment. And you can describe that particular step-by-step procedure and take a memo. And not only for your colleague, but also for yourself. In the end, you have no idea why you did it. So it's very nice to have a memo in between. It's very nice habit. Whenever you have a particular analysis, you describe why you did this, why you have to do this one first instead of the other one, why you include this part and developed by whom, etc. So that's very nice habit, especially when you're doing a large scale big project or working with your colleague, or well, we're getting a forgetful over time, right? So we would like to memorize what we and what we done it, right? Another one is learning syntax. This is very practical tip. First of all, we have no idea, right? And where is my how many procedure SPSS have it? I think there's like a 50, like a nearly 100-ish type of procedure they already have. There's no way to conquer entire procedure, right? And then also we are pretty much okay to using what point and click drop down method, and because we can navigate those entire SPSS process using those drop down menu, right? Even though we never done it in that particular process, we know that kind of like for example when we do regression analysis, 99% we do the what linear regression analysis. But when we navigate that SPSS in analysis button in regression part, there's tons of fancy analysis, right? Fancy regression analysis, right? Called linear and all advanced topic over there, right? So we get to know, and those procedure name and menu title is what pretty much what making sense, and then also we can understand, and there's a other type of analysis there, right? So taking advantage of those traditional drop-down menu button to organizing our thoughts and what are possible other possibility is a fabulous thing. So basically this idea is what teach you, and we understand, not only we are taking advantage of our prior investment onto drop-down button click thing, but also what? And then we can use those things to enhancing our syntax approach, right? First thing you have to do it is when I demonstrate in previous slide, do you remember this one? See, if I run it and upper part of those output, those syntax was what? Displayed. In output, those SPS syntax for this analysis was displayed, right? Key idea is what? To make sure whenever we run analysis, SPSS analysis, let SPSS display that syntax in the SPSS output. So how do we do it? And begin learning analysis, and then you do edit, option, and click viewer. And the lower bottom, right, there is a display comment in the log. Display commands in the log. Commands equal to SPSS syntax, what you used, right? And you can check this button. Unfortunately, this is not a default in SPSS. So you have to go home in your SPSS program, you have to check this button. And then whenever you run analysis, and then they will display this SPSS syntax for you. Even you do what? Point and click method. So go ahead if you are interested in what to learn SPSS regression portion, and go ahead to do it as a traditional point and click regression, run it, and then cut and paste that regression part, integrate it into your SPSS syntax project. Are you with me? So which means what? You don't have to run entire how to write regression analysis syntax, because we already know how to do it in point and click. Point and click method is fabulous because intuitively you can do something. Without knowing anything, you can point and click and play around and make it run, and then cut and paste that command, syntax part, and save it into your sequential syntax project. And then you can building up what? Again, professional work or big scale of work is what? You're not finished only one analysis. You this analysis, save it, deleted it, and then also what? Plug that value into another one and merging it, and then doing another analysis. There's like a sequential work is required, right? Each element of work, if you don't know how to write that syntax, go ahead to do it by point and click, cut and paste into your in-between process. That's exactly I learned my syntax because I'm not learning syntax, memorizing entire those like dozens of procedure by myself, right? And I have a reference book. Every SPSS program, they had a what? Reference book for the syntax. If you want to changing options, but still I'm baseline how I concur the syntax is what? Just go ahead to generate that command by point and click method, and they use that command into syntax process, right? And for example, if you do it, if you click that button into display command in the log, this is just demonstration. If you go ahead to run descriptive statistic by traditional point and click GUI method, and then they will display this frequency variable x1, order analysis, this basic command line for you, and then you can use this command line for the future analysis and then modify this command line, right? That's the whole idea. Right, and paste means what? And then also, when you run this GUI one point and click method, right, graphical user interface, there's a paste button for every window. You never used that one before. There's a paste button in that particular analysis window. Paste means what? You basically copy and paste. You can just set up those analysis. You can paste that particular process into syntax window. They will automatically what? Write this descriptive statistic analysis with x2 variable into syntax window you already open up, right? So you don't have to run it. You just set up, paste, and then they will do it for you. See, this is something happened. If you pasted it because you already open up the editor window, they computer automatically paste that particular type of descriptive statistic function. I mean the module syntax, right, and command, right, into this syntax window. Okay. All right, and the other one, if you are interested in reference, because okay, cool. Now I, like for example, descriptives. This is very important. What? Very, very important, and because even we do the inferential statistic, we need to run descriptive statistic, right? Mean, mode, median, correlation. We need to do, right? Even we do the fancy regression, multi-level structural modeling, and any type of next level inferential statistic, APA still required to run a descriptive statistic. So this is very popular type of thing, and then you like to explore what are options. Making more advanced version of the descriptives, and then what are sometimes the point and click button cannot do everything. So there's a significant portion of analysis you can only do that analysis with syntax version only. So if you are interested in to deep dive into that particular procedure into more, and then you can use this help command syntax reference, and then it will popping up that SPSS manual, syntax manual with like 100 pages of PDF file. You can print that out and save it into your hard drive, or print that out into killing a lot of trees, and and then you can study by yourself, right? Okay. The other one is if you, this is the journal file, and then this is another technical tool. Sometimes you do a lot of analysis and then you got lost. You did a lot of analysis and your output was, you deleted that output. If you can find a JNL file, search your hard drive and JNL. Basically, SPSS save entire your step-by-step process, entire command line, save it into this JNL file. So if you can find this JNL file, and this depends on where it's saved, SPSS saved, as long as you're able to find this JNL extension file, basically you can see entire analysis you have done it in that machine since that SPSS installed. Everything was stored into what? Every command line is stored into JNL file. Sometimes save a lot of monies and other things because you can see, you can rescue entire analysis again, right? This is another good tips. I hope this not happen to your life, but sometimes I run an entire 2 days and 3 days of analysis, and all of a sudden I forgot to save my output file, right? And then I was freaked out. I didn't save entire those process, so I need to find this JNN file and then regenerate the entire analysis again. Okay. And this is just process of where you can be able to save it and locate that journal file. Again, a little bit technical detail, right? But it's good to know at least. So the idea is this, and you don't have to memorize entire thing. Idea is SPSS will save my work, entire my work in somewhere. The file name is journal file, and if you want, you have to find out that journal file, and they use this lecture note. All right. Other thing is just a little bit the extra. Okay, and we spent approximately 40 minutes. And before we moving into this intro level statistical module, right? Have any question so far? So clear? All right. Why don't we have just 1 minute break and 1 or 2 minute break and come back and continue to this second part of lecture. All right. Thank you.
This from China. How many university? Yeah. Science education and stuff. Yeah. Yeah. Conceal and yeah, that's very interesting. Really? Yeah. Because yeah, I specifically I art. Yeah, because I extension. Doctor extension. Yeah, yeah, combine. Yeah, yeah. It's using methods to analysis of data or survey. And yeah, I read your website and introduce what you are working so far. It's very and special. You develop a system, right? Oh yeah. Yeah. Yeah, yeah. I'm very interested because I couple months before I think about because we right now most persons focus on the quantitative assessment, but the traditional methods we just use hands-on labor and but students respond
That's the whole point of that project. I'm still working on it. Yeah. I won't come into talk, right? Okay. Okay, let's check before we moving on. So many people, and yeah, 4 viewers. Cool. There's a 4 people watching this one now. Say hello, you 2 people, and yeah, we will start it the second part of lecture shortly. If I have a multiple windows and then I can see their chatting, and if they have a questions, and then we can address those questions at the same time. But you know, right now the machine only have a 1 window, so I can open up to those to activity in those online people at this moment, right? So, all right. Let's do it, the second part, and make sure that we also recode this computer. Desktop, I don't have to see. Embedded, recode. 3, 2, 1. All right, and then we're here, and then we also share screen, make sure online folks able to watch. And then I lost my pointer. That's okay. Okay, let's do the second part of lecture note. Lecture. All right. Statistical modules. Again, SPSS syntax, they call it as one particular job. They call it as a module, right? And procedure, right? And at this, I mean, same name, procedure or module is the same thing. And we just learned the descriptive module or procedure, right? But I just, you know, picking up some series of modules, I think it's related to introstat level, right? So let's talk about what are SPSS command modules, right? I choose graph, first of all, and also frequencies, right? And I choose, and then also descriptives. Descriptives, we already learned how to do it, and basic structure. And then in this class, and then we will talk about correlations. Of course, why not? This is very popular topic in introstat level, and cross-tab as well. Cross-tab analysis, one of the most popular descriptive statistics, right? We will do. And we will do t-test, right? And there's many, like, you know, this class is not designed to teach statistic behind those modules. I assume you already know those 1 sample, 2 sample, independent, paired t-test, right? Not only above and beyond this, just Pearson product moment correlations and et cetera, right? So it's nice, fun review on introstat level. And I know this audience in front of me, there's 200 people in front of me. I think all of you guys are eligible to teach introstat teacher in some point, right? So even though you're not a stat major, right? Once you got a job, right? And once you got a degree, right? This 200 PhD will eventually what? Ready to teach introstat level component in teaching job, right? So that's the reason why this is very useful not only for doing analysis, but also for what? To understanding stat more in deeper level, and also you're able to teach these things to someone else, right? All right, let's get into graph. Graph had a many chart. Bar chart, pie chart, line chart, error, high-low close, scatter plot, and Pareto chart, right? And then, there's like, which one is the most important, popular one? Bar chart, pie chart, line chart, and also scatter plot is the one of the, there are four most frequently used those graph and chart, right? Very high resolution and publication ready. You already had experience in SPSS. It's not a perfect, the best statistical graphing software, but it works, right, for dissertation and developing professional documents, right, report, and SPSS doing a decent job and produce those graphs, right, and chart, right. And there's options. Again, one more time, how the module name is chart, and then statement and options, right? And you have to understand structure of those tables. And there's some, you can change title and footnote of graph. And also we can change chart type. As a bar means what? Bar chart. Line means what? Line chart. Pie means pie chart. Scatter plot, histogram, scatter plot. It's pretty much those chart type option is what? Intuitive, right? So we don't have to memorize everything, but it's good to know what are all possible charts you can produce. So how do you know how many chart is available in SPSS? Number one is what? Just checking that SPSS syntax reference, or you can point and click chart and click everything, and then you can see nearly every possible options, right? So you can delete some unnecessary stuff out of it, right? And chart contents and how you what number you're using, aggregated data, percentage, raw data, and that kind of thing. You can choose it. Sometimes you like to display those chart with percentage value, display percentage value in pie chart, or sometimes you want to display what? Specific subgroup scores on each groups in pie chart, right? You can change that kind of thing in here. Template is you have like a particular template, you already developed it and save it. You can use those things from over and over, and particular setup of those chart option, and then you keep reusing it. You call it a template, right? Okay, let's do it. Graph is what? One more time. If I write down the first syntax, what is graph? Module name or command name, graph. And then /bar means what? Statement. Okay. I want to have, hey computer, I like to use graph module. Inside of graph module, I want to do bar chart, analysis. And I also use a sum of mother, which is variable will be, and by city is what? Across city, right? And now you compute sum of mother score. This is actually the English version of what? And how we interpreted this statement, syntax. Again, last, you also need to do a dot. That is very important. The most important thing. And you will realize it when you play around with this game. And again, you can use, instead of sum, you can have a count. PCT means what? Frequency. And CUPCT is what? Percentage, right? CUPCT is what? Cumulative percentage. And CUFREQ is cumulative frequencies, right? So what value you're using it into this graph, and then you can choose those options, right? Mm-hmm.
Always separate the module from the statement?
You can have a multiple statement inside of those module, like a graph, /bar, /other thing, /line with another options. The /bar means what? particular analysis. Graph means, hey, computer, I want to use this module, graph module. Slash bar is what? Particular job inside of that module, right? And then the right-hand side of the slash bar equal to some, like more options and details of that bar chart. Using an equal sign in slash bar equal, right? And the second step, second point, right? If you do it and then you're able to, if you use, like, this is another example. Okay, graph, I used it. And then use title equal to what? Title footnote is another particular specification for graph. So you can change title and footnote into title equal to quotation mark. And then also subtitle. And then you can use subtitle with subtitle, statement. And then you can do what? Footnote. You can add footnote by this statement. And then in the end, what? Later moment, what? What was the most important thing? Slash bar is what? I will use bar chart. And also what data you were using in this bar chart, you can specify what? The data will be what? Sum of x1 over x2. See, x2 now becomes what? Categories. The frequency of each x2 category will be what? Sum of x1 value. Okay? So you can replace x1 and x2 whenever you want. Like this is example what? Male and female, and then you like to count what? Anxiety score in stat class over male and female, right? Female students. And female students in my stat class, anxiety always lower than male students because I'm more like female friendly teacher, good teacher, right? So see, in that case, if you want to display what? Sum of anxiety score for female, sum of anxiety score for male, and x2 has to be what? Categorical variable, which is gender, male and female. Right now, I coded it into what? 0 as a female, 1 as a male. And then also, sum of x1 should be what? Anxiety score, right? And then they will automatically do it for you to aggregating entire anxiety score and sum them up. And then they display over 2 groups, male and female, and then they display it in here as a graph and bar chart, we call it. Again, I'm not memorizing these things. I'm basically making this what? I generating this syntax. But sometimes that syntax system not give you detail of footnote, right? Sometimes, in the bar chart that there's it's not clear to how to manipulate in particular part. So a little bit very, very technical part, sometimes you can only do through syntax options to, if you want to decorate, if you want to produce very, very professional, very, very specific figures and diagram, even analysis. So it's good to know baseline should be where? Point and click, generate baseline statement. And then what? If you want to make it very fancier and very professional, you have to study that reference and modify a little bit and then making a better one. That's actually my recommendation to you. Right? And then save that syntax. So you spend a lot of time to produce that beautiful syntax analysis, and you can reproduce that syntax and whenever you want to do it and second additional analysis if you like to do, right? All right. Again, subcommand, it's good to know. I don't want to go over entire subcommand, simple, grouped, stacked, range. There's a whole fancy even bar chart. You can making a very fancy bar chart out of the, by using those subcommand, right? All right, pie chart. Again, same thing. And I don't want to talk about what is pie chart, but same idea. Pie chart, there's a what? Substatement, and substatement including options, and then you're able to create what? Very simple pie chart to very advanced pie chart using syntax as well. SCATTERPLOT as well, right? SCATTERPLOT is one of the most popular type of descriptive statistic or visually displaying your data, especially what? Bivariate scenario, right? SCATTERPLOT is useful for the correlation analysis. Sometimes we need to do the SCATTERPLOT for the regression analysis, right? And visually displaying your data is, I think very, very, I mean, almost it's a necessary to inspect. Even your professionals, don't jumping into inferential, super duper fancier inferential statistic. You have to understand your data set first, how it looks like, right? And pie chart, histogram, and scatter plot is the fundamental process, and we visually inspect and just get to know each other in your data set. If you know when you're dating, well, you have to have a good outcome with your data for your successful analysis. But when you have dating, you're not jumping into serious topic immediately, right? You're also checking hi, low, what's your name, right? And you have a very, and then you need to get to know your data first if you like to conquer your data set, right? So scatter plot and visual inspection is very, very important, right? There's a bivariate, overlay, matrix version, XYZ version, and there's a lot fancier options and specification related to scatter plot subcommand as well, right? Bivariate, overlay, again, bivariate is what? The first scatter plot we did it, just 2 variable only. Overlay is what? If you have a multiple groups, like for example, correlation between X1 and X2, right? And for example, correlation between your SAT score and then also what? GRE score, for example. But you want to decompose into that scatter plot relationship over different ethnicity, Asian or not. Like for example, you want to see the scatter plot relationship between SAT and GRE over to gender. I mean, 2 ethnicities, right? So it's very good. And then before you're doing a super duper multi-sample structure equation modeling, just take a look what's going on. And even bivariate relationship is give you a lot of cool sense what's going on, right? Even multi-level modeling, when we're working on the hierarchical linear modeling, you have to display data in this overlay version. Why? Is it really correlations are same? Scatter plot is same over different groups, right? And heterogeneity of subpopulation is what? The most important reason why you have to think about fancier multi-level modeling or HLM or latent class analysis. So you have to identify those heterogeneity of subgroups, right? Over overlay option. Matrix is what give you X1 and X2 by X1 and X2 scatter plot, X2 and X3 and X2, X4 and X2, X5 and X2. They can just generating all possible pairs, right, of relationship scatter plot into one shot, which is good. XYG is what? Like a 3-dimensional scatter plot, right? Scary thing, right? 3D, right? I'm not talking about 3D virtual reality issue. I'm talking about 3-dimensional scatter plot, right? And visual inspection is very important. And you can find out many cool things out of that visual inspection. All right, histogram. Okay, histogram is a histogram. And I don't want to get into detail. What's the difference between bar chart and histogram? Of course, level of measurement, right? So if our data is what? More continuous-ish, we call it as a what? Histogram instead of bar chart, right? So histogram, okay, you can do, histogram is like whenever your data is metrical, i.e. ratio or scaled ratio or interval scaled score. And one of the most popular assumption is what? Or one thing we like to check is what? How your data is distributed and how close your data is normal, right? How normal-ish, right? So you can check unimodality and you can check symmetricacy and kurtosis, right? And before you compute those fancy statistics related to skewness, and kurtosis, you have to visually inspect first, right? So that's very, very important. And you can overlay in this histogram with normal distribution functions, right? So you can visually conclude, oh, my data is normalish, so I'm okay with that assumption and that concerns, right? All right, frequencies, and frequency is very also important. And when we learn introstat, and we do what? Frequency telling. Okay, how many 1 in this data set? How many 2 in this data set? And then making a frequency table, and then making what? Aggregating up to just before everything, we make it what? Making a what? What is the second column? First column is what? The variable, the data itself. What kind of data there? And second column is what? How many data point for that particular case? And then third column is what? Cumulative frequency. And then also sometimes we divide by total frequency and then with cumulative proportion. And then we construct what? The cumulative frequency chart or cumulative proportion chart. And then we are using that chart as what? Ogive shape chart as what? We call it as a what? Frequency, cumulative frequency table. When we find a percentile rank, percentile score, and then we are using that particular table. If the data is normalish, and then all of a sudden that particular below everything percentage will be exactly computed, and then with any statistical textbook, they included what? Before every percentage or upper percentage into standard normal distribution, and we call it as a what table? Z table. So we are using those Z table for, again, that's actually based on what? X is perfectly normally distributed. There's a 99.9999% of practical data never got perfectly normally distributed in given X. So we are using those X value, create what? That particular variable specific cumulative distribution chart, and then we are using percentile rank and percentile score computation. We are using it, okay? Again, frequency is very important and very popular. Another reason is what? Whenever you use this frequency command, there is an option, statistical display option. So basically you can compute what? Mean, median, mode, standard deviation, variance, skewness, kurtosis, and sum inside of frequency command. That's the reason why it's very popular. And when I need to do it, my descriptive statistic or understanding data set, I will use this frequency as a first. I'm not using descriptives. Why? Because in frequency, there is a descriptives options. So I'm using a one shot when doing a frequency, and then I request all those mean, mode, median things. I can finish one shot, and then I can create those frequency tables, and I can get all descriptive statistics at the same time. Why not? So that's the reason why this frequency command is very popular, and you will be very, often use this frequency command line for the practical use, right? Again, frequencies, you can even have a what? Pie chart too. How nice. Inside of frequency, you can create pie chart, bar chart, and given variable, descriptive statistic, right? That's the reason why, another reason why this frequency module is very popular and useful in SPSS realm, right? All right, and let's try to read this one, decode together. Hey computer, I want to use frequency module. Jaehwa told me frequency module is very popular, and when I use it, right, I will use what? The variable as a sale variable. If you want to use x1 and x2 and another variable, it's just space, another variable name, space, another variable name. You can stacking up the many variables at the same time. Format is I don't need table. No table means no table. And then number of tiles and the 4 tile, right? And and then slash histogram. I need histogram with normal distribution. Normal graph, right? And at the same time, I also need descriptive statistics. Standard deviation, minimum, maximum, mean, median, skewness, kurtosis. And slash order analysis it's not give you any particular thing. but dot, 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 dot. Don't forget that dot. And then if you run it, and then they will give you a beautiful SPSS analysis for you. So it's modifying this, right? And then you will get this kind of analysis. First of all, this is, and then this is right-hand side, another one. This case is what? We use two variables, x1 and x2. And then also I grouped an x2. And I also request percentiles, right? So 5 percentile score, 25 percentile score, 50 percentile score, 75 percentile score, and 95 percentile score, right? Again, this right-hand side, I write down 5, 25, 50, 75, 95 is what? Percentage, below percentage. I'm asking percentile score given below percentage. So percentile in here is what? Percentile score. It's not a rank. I already give them a rank. I plug in the rank, and then I need what? Given below percentage. What is that score to make it as a what? Below percentage, right? So percentile means percentile score. That's the reason why they displayed in here on left-hand side. Okay? So group and frequencies are around more accurate estimate of requested percentile, blah, 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 right? But it's not that much relevant for this case because X1 and X2, basically they displayed that one as it is, whether grouped or not. Okay, correlations, yes. When you do what? Scatter plot, and then you can visually inspect, oh, sort of like upward relationship or downward relationship. There's no up or down, and it looks like in a swarm type of no relationship, right? You can visually inspect sort of, relationship in a more like, not a qualitative way, but anyway, you are not computing a particular value measure out of that relationship, and then you can investigate that relationship inside of scatter plot as it is. And you don't want to stop it. And then you really want to, okay, I understand the Jaehwa upward relationship is what? Like X1 and X2. What do you mean by upward relationship? It's what? Relatively high value X1 associated with relatively high value X2. And the other way around, relatively lower value X1 associated with what? Relatively lower value in X2. So you want to compute that value, that relationship. We call it as what? Measure. Measure of what? Bivariate relationship. And then we compute, and that number try to represent that relationship into a score, right? So correlation analysis give you basically what? Variety of bivariate relationship, not just limited to Pearson's product moment correlation. This correlation is what? More, there's like a covariance, correlations, Spearman's rule, and there's some more relevant to ordinary data, right? There's just like several additional options above and beyond correlation, Pearson product moment correlation value itself. And then they give you matrix, which is correlation between X1 and X2, X1 and X3, X1 and X4, and the other combination as well, right? Again, the correlation is what? Another name of correlation is Pearson product moment correlation. And then they also give you matrix, which is like an entire X1, X4, or you can specify submatrix. I think we will talk about that submatrix. It's very useful when you do the dissertation and professional document. At some point, you don't want to have a what? 30 by 30 matrix. You want to have a what? 10 by 20, 10 by 30, because if you want to publish it into letter size document, you have to chop it up to that a particular part of matrix, right? So SPSS give you some command line to give you the first 5 and the other 30, and second 5 and the other 30, and then you can break it down that entire matrix in a very nice way, so you can put it into regular letter size of paper, right? And also they will include what? Correlation is very important in terms of descriptive statistics, right? But we also learn to making an inferential statistic. So whether we can do what? Hypothesized test, statistical test, whether that correlation is statistically significantly different from 0 or not. So they also produce that hypothesis test, which is they produce significant levels, and and two-tail. Two-tail test is default, right? But you can change that one to one-tail. What do you mean by one-tail? My correlation is not just simply different from 0 or not. I can request what? My correlation is statistically significantly greater than 0. Holding other things constant. Okay, this 200 PhD candidate in this room. So one-tail test is what? Easier to reject or harder to reject than two-tail test? One more time. SPSS tried to do as much as they could make it as a what? Two-tail as default. Some tests you can change two-tail to the one-tail. What's the advantage? What's the rationale? What's the implication of the changing from two-tail to one, just above and beyond greater than 0? In short, one more time, one-tail test easy to reject or harder to reject than two-tail test? So how many of you think about the one-tail test? If you change the one-tail test, okay, I think it's easy to reject. Okay, we have 75, approximately 75 attendants say. So the other 125 attendants will believe two-tail test is easier to reject. Answer is yes, one-tail test is a given direction, right? One-tail test is easy to reject the null hypothesis over two-tail test. So default is more conservative. Default to two-tail test is sort of conservative because we do not allow relatively easy to reject case, right? So again, it's good to know because p-value associated with two-tail test, the SPSS default output is what? Related to two-tail test. So, oh my God, this p-value is too big, so I cannot reject my hypothesis, so I cannot graduate. No. Think about the changing your hypothesis to one-tail. You may be able to find statistical significance. Right? I know that's a cute tip. I don't want to give you the cheating on your data, right? But tip came out from what? Knowledge, right? And training, right? You pay thousands of dollars of tuitions, so it's taking advantage of those knowledges to understand that this statistical game better. I'm not teaching you the dirty tips and how to win the stat game, right? Okay. Anyway, those are statistical options, small option you can manipulate inside of those syntax word, right? Additional statistic, you can ask mean, standard deviation, missing case, cross product deviation, covariance value, right? So you can run, you don't have to run covariance to separately, and you can do it into mean, standard deviation, covariance, sum of cross product type of thing inside of correlation module, command line. All right, again, this is output, and right hand side is what thing. Let me read it in English. Hey computer, I want to use correlations module, and I will use x1 and x2. If you use x3, and then they will give you a matrix with x1 and x2, x3 at the same time. Right now, it's just bivariate relationship. And please print two-tail result, right? And no significant value too. And the missing, in case of missing, please pairwise deletion, not listwise deletion, right? Listwise deletion is what? If you're running a multiple variable, what happened? Listwise deletion. Any part of missing will be out, right? Just completely out. Pairwise deletion is what? If you compare, okay, x3 could be what? Missing. But when you compute x1 and x2 covariance, correlation, and you just go ahead to compute correlation between x1 and x2, you save that particular case. Even x3 is missing. But that case will be excluded when they compute x3 and x1 correlation. And then that is meaning what? Pairwise deletion instead of listwise deletion, right? And Dr. Yu will teach you fancy propensity score and another type of missing, not correlation case, but experimental research to dealing with another route of handling missing data, right? Right now we are talking about missing data is what? It's just non-experimental, typical statistical analysis, missing data analysis, right? All right, look at this. And X1, this is matrix, we call it, and Pearson correlation. Full name is what? Pearson product moment correlation. What do you mean by one in here? Correlation between X1 and X1 by itself is always 1. So diagonal portion should be 1. And 0.167 is what? Correlation between X1 and X2. This is the correlation between X1 and X2. Should be same as what? Correlation between X2 and X1. Why? Because correlation is what? Symmetric. So X1 and X2 correlation should be same as X2 and X1, right? And then second one is what? Sig value, significance value in two-tail, right? If this sig value, and what is another name of sig value? And this is SPSS term. What is our stat training sig, another name of sig value, which will be p-value, right? Dr. Yu, and you're cheating, and you are not allowed to answer in this class. You're a teacher, so you have to be responsible to another students, not yourself, right? Okay, so we can compute this p-value. Is this p-value is greater than our alpha value? We failed to reject the null hypothesis. And then the default null hypothesis of correlation analysis, what? Population correlation between X1 and X2, this case, equal to 0. That is default null hypothesis. Okay, let's move on. Again, it's nice review, right? A cute review, right? We know that, right? All right, and this is more like in this case is what we have a many variable like a food, rent, right, and teacher, cook, engineer, like 1, 2, 3, 4, 5, 6 variables, right? And then in this case we can use the with statement, food, rent, with this the other 4, and then they're not just doing entire 6 by 6 correlation matrix. They produce correlation matrix between what? Food and rent, and the other 4 variable, like a 2 by 4, 1, 2, 3, yeah, 2 by 4 correlation matrix you will analyze. Sometimes you need it. You don't need like other variables correlation. You only focus on what? These variables with the other 4 variable. Right? You're only interested in. So you can specify that part of relationship among those, even though you are using 6 variables, right? Correlation you're interested in into that 2 by 4 situation. So you can specify. This is very cool to me when I do what, like 30 variables and I'm analyzing it, but there's no way to fitting into 30 by 30 correlation matrix in my professional analysis output. So you can chopping up a particular relationship and focus the relationship, and you can display and analyze it. So very, very useful when you want to develop professional document later. All right, this is another example, and you can do, there's tons of other examples, and I just want to point out the last one. This one is what? Slash matrix out, this correlation matrix is what? Sometimes you want to print, or you can save correlation matrix into another data set. And next analysis, we will read that saved data set into another, like a factor analysis. Use that correlation for second step of analysis. Are you with me? Instead of you cut and paste, save into Excel, you do the correlation matrix job by hand. No, let computer do entire process. Hey, I will give you X1 and X2 and X3 and X4 SPSS. Please run correlation analysis and compute that correlation matrix and save that correlation matrix into another data set name and second sequence, and then you read that particular correlation matrix and use that correlation matrix as a data for second step of analysis. Are you with me? This is like, you know, because you use output of first analysis as a second analysis data. Even you use X1 and X2 and X3 and X4 raw data, but you're able to use what? That output of that previous data as a second analysis data part, right? Again, I mean, you can make it fancier, and you know, but this is very simple example and how to use output, how to save your output of analysis into another form, right? And SPSS give you those options, and you can take advantage of those things into you know, building up your own project, right? Cross-step analysis. Okay, cross-step analysis. Another. I think I'm a very big fan of cross-step analysis for some reason. And whenever I like to do bivariate analysis, I always use cross-step analysis over correlation analysis. There's several reasons. Because correlation analysis give you only experience row and Pearson product moment correlations and Kendall's tau. There's only few options for investigating relationship between two variables. But cross-step analysis give you traditional chi-square test of independence and whole bunch of what? Pi index, and whether X1 is categorical or not, or you know, each variable is a normal, ordinal or not, or metrical or not, and then they will provide you nearly every possible measurable association in stat book, and you can analyze that one in a one shot. Especially when you're working with the Likert scale or rating scale data for our dissertation, right? Our stat teacher told you what? Hey, be careful, because we don't know those numbers are what? Completely metrical or not. Very likely what? Those numbers are ordinal, right? If we treat those ordinal, right, ordinal data as if interval or ratio scale data, there's some potential bias and risk associated with that wrong analysis, right? So we are professionals. So these 200 PhDs are not just, well, I didn't learn it. Well, we learned it. So that's the reason why we do our best to, using our, extending our analysis up to at least what we learned it. And cross-step analysis give you the other options and, variety of other options to dealing with, especially for the level of measurement, categorical, ordinal, right? Interval or ratio data, and measurable association among those, over those level of measurement, cross-step analysis give you. Above and beyond correlation, of course they include correlation. That's the reason why I'm not getting into correlation analysis. Jumping into cross-step analysis, I run everything just in case, other option give me different result or not. Above and beyond just Pearson product moment correlation analysis, right? Analyze descriptive statistics cross-step. Okay, let's just double check. This is nice reminder. And what was cross-step analysis? Yeah. So if you do it, that button click, and you will see this kind of window left-hand side. So you can choose as many variables in the rows and columns, right? And then you can even make a layer. If you have another variable, boys and girls, for example, you can make those, cross tabs over layers. So another group membership, right? So, and then also you can have a what? Cluster bar chart you can have. You can suppressing tables as well. The most important thing is what? Right-hand side and upper button, statistic button. If you click the statistic button, and they give you whole bunch of additional measurable association. Number one, chi-square. This is chi-square is what? Pearson's chi-square test for the independent test. They'll do it for you. Correlation means what? Actually, Pearson product moment correlation, right? Nominal is what? If both variables are what? Nominal variable, categorical variable, there's additional measurable association. They also have it. And ordinal is a very popular what? Kendall's tau, and there's other very popular ordinal data measurable association, right? And nominal bar, interval, eta, kappa, risk, McNemer, and you can do some mental hassle statistic you can compute by you clicking in here. Again, I don't. I spend entire lecture to overview those measure of association when we learn these statistics. For now, if you're interested in, and right-hand side, click Help button, and then they will give you additional explanation, and most importantly, what? The reference of each measure. So you can go to that key reference if you like to understand what that measure means, right? And then you can study by yourself. We are almost doctor. What do you mean by doctor? We can research by ourselves, right? That's the difference between doctor and non-doctor, right? So we can teach ourselves. If we want to know where's the resources, we can read, right? We can study, right? And we can building up our own knowledge by researching ourselves, right? All right, and cross-tab analysis, and these are example. First of all, I want to use cross-tab analysis and table. So what type of table I needed? X1 by X2. So like table between X1 and X2. Which one is row and which one is column type of relationship, right? And format is what? And you can choose those default format, statistic, what statistic you're looking for. If you click in the whole bunch of those things in right-hand side in here, and then, you know, chi-square means what? Where this chi-square came from. If you click this chi-square button, and you will able to get this statistics. So it's like a parallel to right-hand side option into, you know, graphical user interface, drop-down menu approach to this statement approach, right? And cells should be count or row data. You can specify those values and percentages. And, you know, I try to explain a little bit on right-hand side, but this is pretty much standard thing, and I don't have to explain, you know, and understandable, right? And if you, I strongly recommend you to do, even this is okay, not play around with this syntax, right? And I recommend you to do what? Click those drop-down menu button and in a point and click method, generate those statement, command statement, and then start to modify that command statement. So make it as that one as a baseline, right? Okay, cross-tab, another cross-tab analysis with regular and overall variable, right? And in here, I ask with the D, BTAU, CTAU, gamma, where that came from? Came from here, right? D, and the right-hand side, and, you know, if you choose those options, and then you will able to get those B, BTAU, CTAU, gamma type of thing. Frankly speaking, I don't remember all those abbreviations. I'm pretty much familiar with all those measurable association in a you know more conceptual level, but I'm not memorizing entire those abbreviation of SPSS. Okay, if you're interested in what this CTAU, what approach? Go to Help, Syntax Reference, Crosstab, and they will have a very details of information about those things. Or in here, click Help button, and then they also give you what that particular value means, right? Okay, that's it. That's how I play around. And I have a SPSS. SPSS has a fabulous job in help and reference. And so I'm not scared. And I have a program. I have a reference. And I can read, right? And then we gotta, you know, everybody got a training on basic vocabularies, right? I can study. And whenever somebody asks you, have you ever done this one? No, but I can find out, what do you want? And then, oh, see you next week. And over weekend, you can go to the library or search Google and play around SPSS. And the next week, you can say what? Your client or your colleague, yeah, I can do it. Give me a data, and I will analyze for you, right? And then you not only give you output, if you want to be a professional, you develop entire syntax and have a nice comment right? This syntax analyzed by what time by me, and then you deliver that entire analysis process to your colleague, and then your colleague will be impressed by your work, professional work, right? All right. Another one is ordinal by ordinal relationship. Okay, these are okay. There are nominal by nominal relationship, which is categorical by categorical relationship with those index. It's good to know. And then also what? Ordinal by ordinal. These are what? Very popular, Kendall's Tau BC type of thing. Especially if you're working with what? The Likert scale data, and it's very likely to your Likert scale data will be ordinal. So this could be appropriate method to checking measurable association, right? And also the kappa is what, more like inter-rater reliability. I think intermediate level training, I will talk about those inter-rater reliability, right? Kappa index. More like a general, I mean another angle, not like a cross-step analysis angle, and then we will talk about those things later. And chi-square test again, and then we already know what is chi-square test of independence between two categorical variable, right? And Pearson's chi-square test, of course, they will give it to you. Okay, t-test. What is t-test? T-test is like, even though when we learn correlation analysis, our stat instructor teach us, oh yeah, you can use correlation as inferential statistic, which is hypothesis testing. You can do it above and beyond just descriptive statistic, right? And t-test is most of cases what? The first hypothesis test. We're doing H sub O, H sub A, right? Alpha, beta, 1 minus beta power, right? And then it's very scary part of lecture. And then sampling distribution of mean, right? What mean of the mean and standard deviation of mean. We cannot call it a standard deviation of mean anymore. We have to call it a standard error of the mean, right? I know we've done it, right? We've done it a long time ago. But t-test is the most popular, very, very popular and also very, very good statistical process. Let me tell you why. Because the t-test requires what? Very small set of assumption, which means what? Statistical conclusion validity. You have a less chance of violating assumption of your analysis. Fancier test is a fancier, good, more statistical control option, but you need to dealing with those violation of assumptions. If your violation of assumptions are fully met and your statistical conclusion is not valid. So t-test is what? Very simple. That's the reason why what? We only need what? Random sample and sample size reasonably greater than 35 and 30 depends on textbook. It becomes a what? You're okay. You don't have to worry about any other things, right? So t-test is very, very good test because of that reason. So whenever you draw a conclusion, right, and you're fine, right? And a lot of super duper study, Nobel Prize winning level study done by t-test, not like multi-level mixture, growth, item response, right? And nominal outcome variable, and with missing, and and fanciness of method is not necessary make your study better. I mean, it's appropriate way of controlling those variables, and statistical treatment is very important, but still it came out from this very robust. I would call it as a robust test. All right, because this is being recorded, so I should not say too much, unnecessary stuff. All right, t-test. What is t-test? We're comparing averages, right? Basically comparing two averages. I'm not talking about two samples. We're comparing two averages, and we are testing what? Two average value is what? Statistically significant or not. I mean, significantly different from each other as a two-tailed case, for example. Or one thing is statistically significantly greater than the other one, right? Even though we are comparing two averages, sometimes we only have one sample average compared to hypothesized average. In that case, one more time, even though we are comparing two group averages, our data is only came from one sample, and the other average we already know, or we already fix, right, as a hypothesized mean. And then that t-test, we call it as a what? One sample t-test. Even we are comparing two averages, right? The other t-test is what? Oh, I don't have that hypothesized mean and right-hand side. I want to compare two groups, but both group I sampled, like a sample, first sample, compute average, second sample, compute average, and then we like to what? Compare two group average, but two group averages happen to be both sample averages. So we call it as what? Two sample t-test. And that two sample t-test had a two different scenario. The first scenario is what? Oh, first group and second group is completely independent each other. What do you mean by independent each other? Hey, boys and girls, that's all. And the number of groups and boys and the number of girls, not necessarily same, okay? So don't have to be balanced, right? But the other case is what? Wife and husband, and son and father, right? Even though two groups are not different people, subject, right? But they're related to each other, either couple relationship or father and son relationship. They are related to each other. We call it as a what? Dependent samples. So two sample t-test decompose into what? Independent sample t-test and dependent sample t-test. So basically t-test module let you run three type of t-test, one sample t-test, and also what? Two sample but independent, or two sample dependent. Or what is another name of dependent sample t-test? Paired t-test. Paired t-test, right? So this is actually, we pair the sample t-test, right? This is actually what we can do. And other analysis, ANOVA, one-way, general linear modeling, and MANOVA, and all other tests is what? A special, you can make it as those fancier analysis as a special case of t-test. What? Even you are doing analysis variance. If you're only working with two groups, all of a sudden becomes what? That analysis variance turns into what? Two sample independent t-test. Okay? So you can do it similar type of thing in regression analysis. If you use your independent variable is dummy coded and your dependent variable, and all of a sudden that slope representing what? Statistical hypothesis testing for that dummy coded 0 group, 1 group. And then that becomes a what? T-test in the independent sample t-test result. It's identical. That's a statistically identical result analysis you're doing it, right? We already know it, right? So again, that's it. And then we do this t-test as simple as, okay, if you want to using those t-test basic specifications, if you want to use it, analyze, compare means. One more time, t-test is what? Comparing averages. Okay, analyze, compare means. Click one sample t-test, and then you can do t-test. Right? And let's try to look at onto left-hand side. Okay, you select one variable x1 and then you like to do one sample t-test. And eventually you will compute what? Sample means out of x1. And then x1 average will be compared to another hypothesized mean. This is one sample case. So even though you're comparing two averages, one sample averages came out from your data, and then what? That sample average need to be compared by hypothesized mean. Hypothesized mean, H sub 0, H sub 8, mu sub H0. It depends on textbook and depends on your stat instructor, right? But in SPSS, they would use it as a test value. So test value, you have to specify test value, hypothesized mean value, mu sub H sub O. mu sub h sub o, right? Or mu sub h, right? It depends on textbook. That you have to specify. And then this process, what? Comparing whether this x bar, what do you mean by x bar? Average of x1 is a statistically significantly different from phi, which is hypothesized value. So hypothesized value can specify in syntax as what? Slash test val equal to 5, right? And variables as x1, and criterion as confidence interval as a 95 confidence interval. Okay, so if you run it in English, and I will doing hey SPSS, I want to do the t-test, and I will use, because x1 only, which means automatically one sample t-test, and I want to use x1 average. I mean, the first x1 average mean is whether statistically significantly different from 5, which is what? Test value. When I evaluated that relationship, statistical test under those comparing two values, I want to go with what? 5% alpha value. How do I know? How do I know? Because I use 95 confidence interval equal to, I want to go with 5% alpha value. With 5% alpha value, I like to test this. So computer compute 95 confidence interval around those sample mean. If this confidence interval contains 5, we will one more time. If this confidence interval, right, contains hypothesized value, we will okay, 50%. Reject or retain. Choose one. We will retain null hypothesis. If this 95 confidence interval computed by SPSS not contain hypothesized value, we will reject the null hypothesis. Now, what is the null hypothesis? The population mean x1 equal to 5. That is a null hypothesis, right? So, okay, nice review. Okay, right. Yeah, and this is typo. Criteria equals 95 confidence interval, not 5 confidence interval, right? This should be, because I type it into 95 confidence interval. It's a middle percentage, not 90%. It should be 95. Okay, and this one, and okay, this one is another t-test. If you want to do the t-test in 2 sample case, you have to choose another menu. But if you want to use a syntax version, you can use the same syntax, t-test command line. In command line, again, left-hand side, you can see this is independent sample t-test case. You have to choose not 1 sample, 2 sample, which is independent sample t-test. You have to choose it by drop-down menu button. But if you use command line, you can use a t-test and groups x01. Let me explain what do you mean by this. Hey, I wanna do what? Average. I want to use variable as x1, but x2 contains group membership. 0 as a first group, 1 as a second group. Right? So x1 is what? The value self you like to do it in. And x2 becomes what? X2 becomes what? Group membership, right? And then variable 1 is what? What mean, mean computed based on what variable, and criteria confidence interval 95 is exactly same. Okay? So you can do one more time. If you want to go with drop down menu button approach, right? And you should use different windows. But if you want to use the syntax, basically same thing, but the right hand side, you can use groups. Automatically, computer understand this is independent sample t-test case.
Does it matter what order you put the commands, or are they interchangeable after the slashes?
After slashes, I don't think so, because they will take it to, because slash missing slash variable slash criteria, I think that they're taking it because yeah, but most of case, up to my knowledge, these are independent options process doing it. They're not, we have to do this one first instead of the other one, right? So you computer take it, SPSS take it, and they plug into parameters and what analysis they have to use it, and then they will run it. But I cannot guarantee, but logically doesn't matter and which one first and which one instead for those slash statement, right? Statement. All right, I mean, good question. I never tried, but good to know. If you find out some other matter, just let me know. I will definitely update my knowledge. Okay, t-test independent sample t-test, if you run it, and then you will get this output. I just want to nicely review, and homogeneity of variance assumption was met or not, and especially independent sample t-test, what is important assumption? Two group variance should be equal to each other in population level, right? Or not statistically significantly different from each other, right? So, and equal variance assumed is what? Homogeneity variance is assumed, right? And right now, p-value, sig value is 0.5, which is fairly not significant for the data assumption, so it's okay. Homogeneity variance assumption, okay, which means what? We will start to read the first line. If not okay, we will go to the second line. But it's not okay, it's also dangerous, right? Because we are comparing two averages. Two averages need to footing up to reasonable same scale, right? Even we adjust a little bit, but still, humongous amount of differences among two groups is dangerous when we're comparing. Variance is metrics. Variance should be reasonably similar when we are comparing averages. Otherwise, all of a sudden it turns out what? Apple and orange comparison, right? Right, p-value is greater than 0.1. For what p-value I'm talking about? I'm talking about p-value in first, 2, 3, and the fifth column. Sig value is greater than even 0.1. So this is very not statistically significant. In conclusion, we retain null hypothesis, right? Even one tail, it turns out not statistically significant. Okay. I know we're tired, right? And we still have 8 minutes. I'm very good at calibrating this one into 2 hours, exactly 2 hours, right? So how many slides do we have? 1, 2, yeah. See, only 4 more, couple of more slides. So I'm good in terms of pace, right? Paired sample t-test, either pre-test, post-test, or two pairs of variables are related to each other, right? So we are using pairs instead of groups, right? Pairs with X with X3. So now you're pairing X1 and X3. That's it. Now all of a sudden, SPSS give you paired t-test. Again, if you want to set up this paired t-test on the left-hand side and then save it into that result and using that paired t-test result to another one and aggregating, and that's the pain of your butt, right? But if you use this syntax, very easy. You can just do it x1 and x3, x1, x2 separately or independently to pair the t-test. Very, very easy to do with it. Using only just what? Pairs option. Again, one more time. Independent sample t-test, you use groups. Dependent sample t-test, you use what? Pairs. X1 with another variables. That's it. And then this is result out of it, right? Of the paired sample t-test. What do you mean by mean? What do you mean by this mean? What do you mean by mean? Mean is what? Mean differences. Full name is what? Mean difference. X1 mean and X2 mean differences. Mean differences. Standard deviation is what? Standard deviation of difference score. So you can make it an X1, X2. You can create deviation difference score between X1 and X2. Third column, right? And then we call it a D score. And then you can compute the standard deviation of that D score, right? Standard error mean is the same thing, either, and then square root of that Standard deviation of different score divided by square root of n give you standard error mean. Confidence interval, same thing. This confidence interval contains, right now, what is the hypothesized value for this case? Default. What is hypothesized value for this case? 0. I give a hint. This is how much stronger hint I need to give you. And paired sample t-test hypothesized mean is default is 0. So this confidence interval contains 95 confidence contains 0 inside. We will retain null hypothesis or reject null hypothesis. We will retain null hypothesis. But right now, 0 is not contained in this confidence interval. Hypothesized mean is not contained inside of this confidence interval. So we will reject null hypothesis, which is same as what? P-value should be very small or big? Very small. Very significant. Very small p-value. What is the name of p-value in SPSS? Sig value. And how small is it small? Smaller than my alpha value to go with. Right now, it looks like a 5% as default alpha value. So we will reject the null hypothesis. Entire process statistical analysis is what? This is t-test. What t-test? Paired t-test. Dependent sample t-test, another name. Okay? Okay. Done. We did it, this SPS syntax. Why we have to learn this? And statistical module intro level, amazing. And we go over entire introstat stat sequence within an hour, including syntax, structure, rationale, why we have to learn, right, today. And next one, on today, and Dr. Ryoo tried to do, as parallel as we can to using R syntax, right? And then next one, November workshop, and then we will come back. I will come back and we do a little bit intermediate level, which is non-parametric correlation, one-way ANOVA, and reliability analysis. I don't know I have a time or not, but partial correlation, regression, and general linear modeling thing in next class as much as I could. And a little bit intermediate, maybe in future we will working with those data manipulations, saving, export, transformations, and do roof, right? And we try to do it in sequential next level workshop. Okay, we still have a 3 minutes. What's up from you guys? What is your question, concerns, and anxiety, and whatever, right? What? Okay, question, right?
This is like a general question, but if you have a correlation matrix,
Okay.
and you're trying to get it in, APA format,
Okay.
is the best way to just export the table and then transfer it yourself?
Yeah, I will give, what I do is just cut and paste that output, SPSS output into Excel and formatting in Excel. SPSS give you some formatting option but sometimes it's way easy to just cut and paste SPSS output into Excel. Excel is more powerful in formatting and changing and and then cut that SPSS formatted table into Word document and in analysis. That's actually what I do. That's the best quality in the end. If you want to publish and dissertation, a little bit okay, but if you want to publish document and they prefer editable level of table. Otherwise, if you give them an image, unless you have a super duper great image, and if they don't like it, if you give them a more Excel spreadsheet or Microsoft Word table version, they're easy to edit for your publication. So, okay, all right.
Silly question, but do you always type in all caps when you syntax?
I think we have to type into those module name as all caps. I think. Again, SPS syntax is very sensible. So when I do it again, I'm not writing up entire module by myself and from scratch. I always use generate those syntax and then modified it. Whenever I generate it, they have all caps. So I'm very lazy person. I never dare to try to, what if I choose this one as a lower letter instead of cap? I'm not that much creative. Just do it as it is and make it work and then start from there. But that's a very creative question. Go home, try to do it. Let me know. Okay, any other question? All right, thank you so much. And hello, YouTube online, and then we will stop broadcast, and then and we will have a 5-minute break, but we will have another video live streaming start in a 5 minutes. So even though this one is ended for now, but we will start another broadcast. Thank you.